Hello students, hope you are doing well. In this video we are going to discuss network management protocol and features part 2 of unit 2 is structuring and modularizing the network for the subject enterprise network design of B7 semester IT, University of Mumbai. In this video we are going to cover Armon version 1, Armon 1 group, Armon 1 and 2 and Armon 2 groups, NetFlow and CDP and Syslog accounting. Before this video, we have covered in previous video. These are the protocols, network management architecture, standards, protocols, SNMP different versions and MIB. So let us now start with Armon. Armon, it is a MIB that provides support for proactive management of LAN traffic. The Armon standard allows packet and traffic patterns on LAN segment to be monitored. Armon takes these items, number of packets, packet size, broadcasts, network utilization, error, and conditions such as Ethernet collision, and statistics for host including error generated by host, VGS host, and which host communicate with each other. So these are the different things. And if we see the MIB of Armon, it is 1.3.6.1.2.1.16. So this shows Armon. Okay. So here we can see what is inside that Armon standard. Fine. Armon is defined as a portion of MIB2 database RFC 2819 RFC 2819, a remote network monitoring management information base, defines the object for managing remote network monitoring devices. RFC 1513 RFC 1513, it is token ring extension to the remote network monitoring MIB, defines extension to the Armon MIB for managing IEEE 802.5. This is token ring network. Token ring network. This is RFC and this is IEEE standard. Okay. Without Armon, a MIB could be used to check the device network performance. However, doing so would lead to a large amount of bandwidth required for management traffic. By using Armon, manage traffic itself via Armon's agent, collect and store the data that would otherwise be retrieved from MIB frequently. Armon agents can reside in routers, switches, hub, server, host, or dedicated Armon probes. So everywhere we can send the Armon agent because Armon can collect a lot of data. Dedicated Armon probes are often used on routers and switches instead of enabling Armon agent on these devices. Performance threshold can be set and reported on if the threshold is breached. This helps reduce management traffic. Armon provides effective network fault diagnosis, performance tuning, and planning for network upgrades. So whenever we are using probes, these probes are constantly checking the Armon network or constantly monitoring. Actually, this protocol is monitoring protocol, remote monitoring protocol. So probes are very important. So everywhere it is probing. Everywhere means it probes for switches, hubs, servers, hosts, or dedicated Armon probes. So probes are very effective things. They are constantly checking for the errors, traffic, and all other information. So these probes are installed at different points. Okay. Now come to Armon 1. Armon 1 works on data link layer. First thing is that it works on data link layer with MAC address and provides aggregate LAN traffic statistics and analysis for remote LAN segment. Because Armon agent must look at every frame on the network. Every frame on the network. Why? Because it works on data link layer. Okay. So because every Armon agent must look at every frame on the network, they might cause performance problem on managed device. Fine. So due to this performance problem, why this performance problem occurs? Because of processing overhead. So many times if you are looking for every frame which is of your use or not, this will definitely cause the performance problem. The agent's performance can be classified based on processing power of memory. So let us see the Armon's group. Here, different groups are shown for Armon: statistics, alarm, host open, filters, history, host, matrix, and so on. Packet capture, token ring, these are the different groups. So initially we start with statistics. It contains statistics such as packet sent, byte sent, broadcast packet, multicast packet, CRC errors, RUNTS, GIANTS, fragments, jumpers, collisions for each monitored interface on the device. Okay. History. It is used to store periodic statistical samples for later retrieval. So it is history. Now come to alarm. Alarm is used to set a specific threshold for managed object and to trigger an event on crossing the threshold. This requires an event group. It is setting for, like, if you want to perform particular operation and if you want to check for alert, so you need to set particular threshold value. On the basis of this threshold value, if it is crosses, then automatically it will give a signal through alarm. Next is host. It contains statistics associated with each host discovered on the network. Then host of an it contains statistics for hosts that top a list ordered by one of other observed variables. Next is matrix. So it obviously shows some measurement. Contains statistics for conversation between set of two addresses including number of packets or byte exchange between two hosts. Next, filters. Filter, whenever we are talking about filter, it is set of rules. Okay, so it contains rules for data packet filters. Data packet match by these rules generate events or they are stored locally in packet capture group. Next is packet capture. Okay, so filter is responsible for packet capture group. Now come to packet capture. Packet capture, it contains data packet that match rules set in the filter group. Next is events. So it controls the generation and notification of event from this device. Then token ring. Here it is. Token ring contains the tokens like ring station. Ring station details statistics on individual station. Ring station order list of station currently on the ring. Ring station configuration information and insertion or removal data on each station, and source routing statistics on source routing such as hop count, number of hops are there. So this is one more diagram for Armon groups. First is statistics, current statistics, history, statistics over time, alarm predetermined threshold watch, host tracks individual host statistics, host top and statistically most active host, matrix conversation statistics between A to B, filters packet structure and content matching, packet capture, collection for subsequent analysis, events, a reaction to predetermined conditions, and token ring Armon extensions. Armon 1 and Armon 2. These are the two things. Here you can see in this diagram that Armon 1 lies in data link layer and physical layer, while Armon 2 is in upper layer. So Armon 1 only provides visibility into the data link layer and the physical layer. Potential problems that occur at higher layer still require other capture and decode tools. Because of Armon 1's limitation, Armon 2 was developed to extend functionality to upper layer protocol. So this is shown in this particular figure. You can see that Armon 2 is not a replacement of Armon 1, but it is extension of it. Armon 2 extends Armon 1 by adding 9 more groups that provide visibility to upper layer. With visibility into upper layer protocol, the network manager can monitor any upper layer protocol traffic for any device to or subnet in addition to MAC layer traffic. Armon 2 allows the collection of statistics beyond specific segment MAC layer and provide an end-to-end view of network conversation per protocol. The network manager can view conversation at the network and application layer. Therefore, traffic generated by a specific host or even a specific application, for example, a telnet client or a web browser on that host can be observed. So here you can see that Armon 1 is written here. It is coming under RFC 2819 and Armon 2 is RFC 4502. So these are the extension. It is already given. Statistics, history, alarm, host top and matrix, filter, capture, events, and token ring. While this point 16 shows Armon and then different groups are there. And similarly for new standard protocol directory and so many different groups are shown here. Okay, so let us discuss each one by one. So these are the Armon 2 groups. First thing is protocol directory. It provides the list of protocol that the device supports. Protocol distribution contains traffic statistics for each supported protocol. Address mapping contains network layer to MAC layer address mapping. Okay. Then network layer host contains statistics for network layer traffic to or from each host. Network layer matrix contains network layer traffic statistics for conversation between pairs of hosts. Application layer host contains statistics for the application layer traffic to or from each host. Application layer matrix contains application layer traffic statistics for conversation between pair of hosts. User history collection contains periodic sample of user specified variable, and then probe configuration provides a standard way of remotely configured probe parameters such as trap, destination, and out of band management. So in this map, different thing. So first thing is protocol directory. So this is protocol, small protocol directory. Then second is protocol distribution. So protocol distribution. Next is address mapping. So it is ADDRESS map. Protocol directory, it is 0.11 standard, 0.12 standard, 0.13 standard. Then network layer host, NL host, 0.14. NL matrix, NL matrix. This is 0.15. Then AL host. It is very simple. You can easily remember it. 0.16. Then AL matrix. AL matrix. It is 0.17. Then user history, USRHISTOR user history. And then finally probe configuration, probe config. So this is how Armon 2 group is there. NetFlow. Cisco NetFlow is measurement technology that measures flow that pass through Cisco devices. So this is associated with Cisco and its flow. NetFlow was originally implemented only on larger devices that pass through Cisco devices. It is now available on other devices including ISRS. NetFlow answers the question of what, when, where and how traffic is flowing in the network. NetFlow data can be exported to network management application to further process the information, providing tables and graphs for accounting and billing or as an aid for network planning. The key component of NetFlow are the NetFlow cache or data that stores IP flow information, and NetFlow exports or transport mechanism that sends NetFlow data to a network management collector such as NetFlow collection engine. NetFlow collected servers uh, data serves as basis for set of application including network traffic, accounting, users base, network billing, network planning, and network monitoring. NetFlow also provides measurement for quality of service application. It captures the traffic classification or precedence associated with each flow, thereby enabling differentiated charging based on quality of services. The important thing to know is a network flow is unidirectional sequence of packet between source and destination. Okay. Now, network flow are highly granular. Both IP address and transport layer applications port numbers identify flow endpoints. NetFlow also identifies the flows by IP protocol type, TOS, and input interface identifier. Non-NetFlow enabled switches or switching technology handles incoming packet inadequately with separate serial tasks for switching, security services, access control list, ACL, and traffic measurement that applied to each packet. Processing is applied only to a flow's first packet with NetFlow enabled switching. Information from the first packet is used to build an entry in the NetFlow cache. Subsequent packets in the NetFlow are handled via single streamlined task that handles switching, security services, and data collection concurrently. Multi-layer switches support multi-layer NetFlow. Therefore, NetFlow services capitalize on the network traffic's flow nature to provide detailed data collection with minimal impact on router performance and efficiently process ACLs for packet filtering and security services. So this diagram shows NetFlow infrastructure. NetFlow can be configured to export data to a flow collector, a device that provides NetFlow exports, data filtering, and aggregation capabilities such as NetFlow collection engine expires flow are grouped into NetFlow export datagram for export from NetFlow enabled device. So the focus of NetFlow used to be an IP flow information that is changing with the Cisco implementation of generic export transport format. NetFlow version 9 V9 export format is a flexible and extensible export format that is now on the IETF standard tracks in the IP flow information export. This is IPFix working group. IPFix export is a new generic data transport capability within Cisco router. It can be used to transport performance information from router or switch, including layer 2 information, security detection, and identification information. IPv6 multicast MPLS and border gateway protocol BGP information and so forth. NetFlow enables several key customer applications including accounting and billing. So this accounting and billing part is here. Okay, what is inside that? Because flow data includes details such as IP addresses, packet and byte count, timestamps, and application port number, NetFlow data provides fine-grained metering for highly flexible and detailed resource utilization accounting. For example, service providers can use this information to migrate from single fee flat rate billing to more flexible charging mechanism based on time of day, bandwidth uses, application uses, quality of services, and so forth. Enterprise customers can use information for departmental cost recovery or cost allocation for resource utilization. If you have knowledge of cloud computing, then you can understand whatever technology or whatever terminology is coming here. Network planning and analysis. Second module is network planning and analysis. So here it is given, and this is also very important because without analysis you won't be able to forecast or use the network efficiently. So what is inside that? NetFlow data provides by information for sophisticated network architecture tools to optimize both strategic planning, such as whom to pair with backbone upgrade planning and routing policy planning, and tactical network engineering decisions such as adding resources to routers or upgrading link capacity. This has the benefit of minimizing the total cost of network operation while maximizing network performance, capacity, and reliability. Now come to network monitoring. So it is also integrated part of this network monitoring. NetFlow data enables extensive near real-time network monitoring to provide aggregate traffic or application-based views. Flow-based analysis techniques can be used to visualize the data patterns associated with individual routers and switches on a network-wide basis. This analysis provides network managers to proact with proactive problems detection, efficient troubleshooting, and rapid problem resolution. So this is how network monitoring is done. Now come to application monitoring and profiling. So network monitoring is also done. Network monitoring. Next is application monitoring and profiling. NetFlow data enables network manager to gain access time-based view of application uses over the network. Content and services providers can use this information to plan and allocate network and application resources such as a web servers, sizing and location to meet customers' demand. Use next is user monitoring and profiling. So user monitoring here application, now user monitoring and profiling. So what is inside that? NetFlow data enables network manager to understand customer and user network utilization and resource application. This information can be used to plan efficiently allocate access backbone and application resource and detect and resolve potential security and policy violation. Next is NetFlow data warehousing and data mining. So next is NetFlow data warehousing and data mining. In support of proactive marketing and customer service programs, NetFlow data or information derived from it can be warehoused for later retrieval and analysis. For example, you can determine which application and services are being used by internal and external user and target them for improved services. This is especially useful for service provider because NetFlow data enables them to create a wider range of offered services. For example, a provider can easily determine the traffic characteristic of various services and based on this data provide new services to the user. As an example, such services is voice over internet protocol which requires quality of service adjustment. The service provider might charge users for this service. NetFlow versus Armon information gathering. NetFlow can be configured on individual interface, okay, thereby providing information on traffic that passes through those interfaces and collecting the informations like source and destination interface and IP address, input and output interface number, TCP or UDP is source port and destination port, number of bytes and packets in the flow, source and destination autonomous system numbers for BGP, time of day, and IP TOS. Compared to using SNMP with Armon MIP and NetFlow's information gathering benefits including greater uh, greater detail of collected data, data time stamping, support for various data per interface, and greater scalability to a large number of interface. Armon is also limited by size of its memory table. NetFlow's performance impact is much lower than Armon's, and external probes are not required. Next protocol is CDP. CDP is a Cisco's proprietary protocol that operate between Cisco devices at data link layer. CDP information is sent only between directly connected Cisco devices. A Cisco device never forward a CDP frame because it is Cisco's proprietary. CDP enables systems that support different network layer protocols to communicate and enables other Cisco devices on the network to be discovered. CDP provides a summary of directly connected switches, routers, and other Cisco devices. CDP is a media and protocol independent protocol that is enabled by default on each supported interface of Cisco device such as routers, access servers, and switches. The physical media must support subnetwork access protocol encapsulation. So here you can see that these are the upper layer addresses, Cisco proprietary data link protocol and media supporting SNMP, and the level like in TCP IP, novel IPX protocol, Apple Talk and others. Cisco proprietary protocol CDP discovers and shows information about directly connected, only directly connected Cisco devices, and media supporting SNAP, that is LANs, frame relay, ATMs, and others. Now come to CDP information. What are that? Okay. Information in CDP frames includes device ID, the name of neighbor device, and either the MAC address or the serial number of device. Local interface, the local on this particular device interface connected to the discovered neighbors. Hold time, the remaining amount of time in second that the local device holds in the CDP advertisement for a sending device before discarding. Capability list, the type of devices discovered are for router, T for transceiver, B transceiver bridge, B for source routing bridge, S for switch, H is host, I is IGMP, and R is the repeater. Platform, the device product type. Port identifier, the port identifier number on the discovered neighbor on which the advertisement is sent. This is the interface on the neighbor device to which the local device is connected. And finally, the address list. All network layer protocol addresses configured on the interface or in the case of protocol configured globally on the device like IP network, inter-network packet exchange, and DEC net. So here now we can show the how CDP works. So there are different switches and routers connected with this. As already shown that CDP information is sent only between directly connected Cisco devices. In this figure, the person connected to switch A, this person is connected to switch A, okay, can see the router and two switches directly attached to switch A, this switch B and the router. Other devices are not visible via CDP. So for this example, the person would have to log into switch B to see router C with CDP. So here this fellow has to log, and then if he want to see this, he need to log in from B. CDP is a Hello based protocol, and all Cisco devices that run on CDP periodically advertise their attributes to their neighbors using multicast address. These frames advertise a time to live value the whole time in second. That indicates how long the information must be retained before it can be discarded. CDP frames are sent with a time to live or TTL values that is non-zero after an interface is enabled. A time to live value of 0 is sent immediately before an interface is shut down, showing other devices to quickly discover the neighbors. Cisco devices receive CDP frames and cache the received information. It is then available to send to the NMS via SNMP. If any information changes from the last received frame, the new information is cached and the previous information is discarded, even if it is time to live value has not yet expired. CDP is the only default and operates on any operational interface. However, CDP can be disabled on interface or globally on device. Consequently, some caveats are like do not run CDP on link that you do not want discovered, such as internet connections. Do not run CDP on link that do not go to Cisco devices directly. For security reasons, block SNMP access to CDP data or any other data from outside your network and from subnets other than the management station subnet. So then come to Syslog accounting. A system messages and error reporting service is essential component of any operating system. The Syslog system message service provides a means for the system and its running process to repeat system state information in a network manager. Cisco devices produce syslog messages as a result of network event. Every syslog manager contains a timestamp if enabled, severity level, and facility. This particular figure shows example of syslog message produced by Cisco iOS software. The most common measures are those that device produces upon existing configuration mode and the link up and down message. If ACL logging is configured, the device generates syslog messages when packet match the ACL condition. ACL logging can be useful to detect packets that are denied access based on security policies that is set by ACL. So this is how syslog message we can see that configure 1, link 5 has changed, line photo 5 up down, link 3 up down, etc. And syslog messages contain up to 80 characters. A person sign follows the operational sequence. Okay, so this is the percent sign which follows the operational sequence number or time step information if configured. So time step information is also given. Syslog messages are structured like first thing is sequence number here, sequence number followed by timestamp, followed by percent, facility, severity, then mnemonic, and finally description. These are the things. Okay. Syslog message parameters. So there are several styles of writing. First thing is sequence number. Okay, so this appears on the syslog message if the service sequence number global configuration command is configured. Now come to timestamp. Timestamp is written in different format. For long uptime it is day and hour. For short uptime it is hour, minute and second. And by default it is month and date with time. So this is how timestamp can be used. Facility, here it is written. Facility, a code consisting of two or more uppercase letters that indicates the facility to which the message refers. Syslog facility and services identifiers used to identify and categorize system state data for error and event message reporting. A facility can be hardware device, a protocol, or module of system software. The Cisco iOS software has more than 500 different facilities like IP, OSPF, SYS, IP security, RSP, F, and link. These are the different facilities. Other facilities like CDP, QoS, Radius, Multicast, MLS, TCP, VLAN, Trunking Protocol, VTP, Telnet, and Trivial File Transfer Protocol. Now come to severity. A single digit code from 0 to 7. Okay, this is the single digit code 0 to 7 that reflects the severity of condition. The lower the number, the more serious the situation. Syslog defines these sequence: alert level 1, critical level 2, error level 3, warning level 4, notice level 5, information level 6, and debugging level 7. Now come to mnemonic. This mnemonic, it is a code that uniquely identifies the error message. And finally come to description. A text string that describe the condition, the portion of message sometimes contain detailed information about the event, including port number and network address or addresses that correspond to location in the system memory address space. So this is Syslog distributed architecture. Here Syslog server is resides, Syslog messages, routers and switches, Syslog messages, remote filters, remote Syslog daemons. So Syslog messages are sent to console session by default. Okay. A device must be configured to send Syslog messages elsewhere. The configuration includes the address of the NMS or another device. Network devices can be configured to send syslog messages directly to the NMS or the remote network host on a syslog analyzer is installed. A syslog analyzer conserves bandwidth on WAN link because the analyzer usually applies different filters and send only the predefined subnet of all syslog message it receives. The analyzer filters periodically forward message to be the central NMS. For example, the analyzer could filter ACL logging data from other router or which syslog entries to ensure that ACL logging data does not overwhelm the syslog reporting tools. The Syslog Analyzer is Cisco Work Resource Manager, essential application that supports a distributed Syslog server architecture to localize collection, filtering, aggregation, and forwarding of Syslog data to central Syslog server for further processing and analysis. The Syslog Analyzer also supports reporting functions to automatically parse the log data into predefined or custom format for ease of use of readability. When it receives a syslog message, the NMS applies filter to remote unwanted message filter can also be applied to perform action based on received syslog messages, such as paging or emailing the network manager. So syslog data can consume large amount of network bandwidth and might require a very large storage capacity based on number of devices sending syslog message. The syslog facility and severity levels set for each, and any error condition that may trigger excessive log message. Therefore, it is important to enable logging only for network facilities of particular interest and to set the appropriate severity levels to provide sufficient but not excessive details. If the collected data will not be analyzed, do not collect it. This is very important in syslog. Selectively filter and aggregate syslog data that distributed or centralized syslog servers receive based on the requirement. So in this part 2, we have covered Armon, NetFlow, CDP and Syslog. With this we finish unit number 2. So we have covered the hierarchical network models, three layer, access distribution and core. The Cisco SONA framework that integrates enterprise-wide network. The Cisco Enterprise Architecture functional area like enterprise campus, enterprise edge, service provider, enterprise branch, enterprise data center, and enterprise teleworker. The infrastructure services and application networking services used within the Cisco Enterprise Architecture model. Security services to provide protect network resources and user from internal and external threats. High availability services to ensure adequate connectivity for mission critical application. Voice services to support VoIP and IP telephony. Wireless services to support mobile clients connecting to enterprise network. ANS to make the network aware of content carried across it and to optimally handle that content. And finally, network management protocols and features including SNMP, MIB, Armon, NetFlow, CDP, and Syslog. So with this, we conclude the unit 2. Now come to sample questions like describe the role of each layer in hierarchical network model. What features of multi-layer switch could be used in the access layer? Which layer in hierarchical model provides media translation? What is the benefit of using multi-layer switching in the core network layer? What are the 6 major functional areas in the Cisco Enterprise Architecture? What are the modules and layers within the Enterprise Campus functional area? The Enterprise Edge functional area includes which module? The Service Provider functional area is composed of which module? How does SNMP version manager request a list of data and what components are required for IP telephony and how are private MIP definitions supported? So these are some sample questions. Likewise, other questions also asked in the examination. So all these things you need to study the video thoroughly. In next video, we will start Unit 3, Designing Basic Campus and Data Center Network with topic Campus Design Consideration. So thank you very much. Have a nice day. Have a nice